The universe is a vast expanse filled with countless stars. Amid these stars, many harbour planets known as exoplanets. An exoplanet is a planet that orbits a star outside our solar system. Detecting these distant worlds is no easy task. Stars shine so brightly that their light often drowns out any accompanying planets. Spotting exoplanets is like finding a firefly next to a searchlight from miles away. Traditional telescopes struggle to capture these faint objects. Astronomers have developed ingenious methods to overcome this obstacle. Each method has its own strengths and limitations, revealing the hidden worlds around us. Exoplanet detection is not just about finding planets. It's about understanding the vast array of planetary systems in our galaxy. These discoveries spark our imagination and drive us to learn more about the universe. Why do we care about finding exoplanets? The discovery of these distant worlds helps us understand planetary systems. Each new exoplanet challenges our theories about planet formation and dynamics. They reveal the diversity of planets, from gas giants to rocky Earth-like worlds. Exoplanet discoveries also fuel the search for extraterrestrial life. Finding a planet in the habitable zone where liquid water can exist is thrilling. Water is essential for life as we know it. Thus, habitable zone planets are prime targets in the quest for alien life. Studying exoplanets allows us to compare these distant worlds with our own solar system. This comparative planetology helps us understand Earth's place in the cosmos. It shows us how unique or common our planetary system might be. The quest for exoplanets also drives technological advancements. These advancements improve our capability to explore space, benefiting other areas of astronomy. Thus, exoplanet research is a cornerstone of modern astrophysics. One of the first successful methods to detect exoplanets is the Radial Velocity Method. This technique relies on the Doppler shift. When a planet orbits a star, it exerts a gravitational pull on the star. This causes the star to wobble slightly. Astronomers measure this wobble by observing changes in the star's light spectrum. This movement indicates the presence of an orbiting planet. The Radial Velocity Method led to the discovery of 51 Pegasi b in 1995. 51 Pegasi b, a gas giant, marked a milestone in exoplanet research. Despite its limitations, it remains a crucial tool in the hunt for exoplanets. The transit method is a powerful technique for finding exoplanets. It involves observing a star for periodic dimming. When a planet passes in front of its star, it blocks some of the star's light. This causes a temporary dip in brightness. Astronomers infer the presence of a planet from this dimming. Launched in 2009, Kepler has discovered thousands of exoplanets. The transit method is effective for finding distant planets. It can detect smaller, Earth-sized planets. Despite challenges, it has revolutionized our understanding of exoplanetary systems. Gravitational microlensing is a unique method to detect exoplanets. It relies on the gravitational field of a star to bend and magnify the light of a more distant star. If a planet orbits the nearer star, it can create a detectable signal in the light curve. This method can find planets that are far from their parent stars. It is particularly useful for detecting planets in the galactic bulge. One notable discovery using microlensing is OGLE 2003 BLG 235L. This event revealed a planet several times the mass of Jupiter. Microlensing events are rare and unpredictable. They require monitoring millions of stars to catch the occurrence. The fleeting nature of these events also makes follow-up observations challenging. Despite these hurdles, microlensing remains a valuable tool. It complements other methods by exploring regions and types of planets that are otherwise hard to detect. This diversity in detection techniques enriches our overall understanding of planetary systems. Direct imaging is the most straightforward method. Taking pictures of exoplanets, however, it's also the most challenging due to the overwhelming brightness of stars. Advanced instruments like VLT Sphere use techniques to block out the starlight. Direct imaging provides valuable information about the planet's atmosphere and orbit. It has led to the discovery of several exoplanets. Future advancements in telescope technology promise to improve direct imaging. Instruments like the James Webb Space Telescope will enhance our ability to study exoplanets. These advancements will allow us to explore their atmospheres and search for biosignatures. The quest to discover exoplanets is a fascinating journey. As technology advances, so does our ability to explore these distant worlds. Remember to subscribe to learn more about our universe, like and comment to share your thoughts, and share this discovery with your fellow cosmic friends. Together, let's unlock the secrets of the cosmos, one exoplanet at a time. Take care of one another and remember to always be looking up.